Hello everyone. I decided to switch things up for today, so instead of watching a Khan Academy video through Delta Math, I am going to teach you myself. Hopefully this is a nice change of pace for everybody. Hopefully everybody is doing well, staying safe, staying healthy, and let's get started. So last week you spent most of the lessons learning how to evaluate limits graphically. I know a lot of people picked it up quickly, and a lot of people had to do quite a few problems before they got to the 5 correct per section. So but now we're kind of moving on from the graphing. We will do a little graphing practice at the end of this lesson for those who might want some review. But otherwise, we are moving on to evaluating limits algebraically, sometimes called direct substitution. Now, I'm just going to preface this video by apologizing. I hope my handwriting is neat enough. My stylus, of course, decided to stop working, and perfect timing, of course. But so hopefully I'm going to try and write as neat as possible, and hopefully you guys are able to follow along. So just for a little do now problem review from our limits graphically, if I wanted to evaluate the limit as x approaches 1 from the left, remember that little negative sign in the exponent does not mean that we are approaching -1, it means that we are approaching 1 from the left-hand side. So right around here, if I can get it, is 1. And so if I'm approaching from the left, that means that I am following the graph along from the left-hand side, and I'm looking, as I approach 1 from the left, I'm looking for the y value that I'm getting closer and closer to. And that y value in this case seems to be 0. Now I'm going to go, and we're going to do the same thing coming from the right-hand side, because since I have now that little plus sign exponent after the 1, that means that I want to evaluate coming from the right-hand side. So again, my goal is to get kind of right to this point, but now that I'm coming from the right-hand side, I'm following the graph along on the right, and then looking to what I'm getting closer and closer to, what y value I am as I approach x equals 1, and that y value also is 0 in this case. Now, in order for the overall limit to exist, which is this notation here, and I know it's the overall limit because there is no exponent at 1, right? There's no plus or minus sign, it just says as I approach 1. So if I'm looking for the overall limit, that means I want to know, does the left-hand limit equal the right-hand limit? Well, those are the two things that you just found in part 1. This was the left-hand limit, and part 2, this was the right-hand limit. So because those two values were both equal to 0, that means my overall limit is also at 0. It exists and it is at 0. Okay? If the right-hand limit and the left-hand limit, if these two numbers were not equal to each other, then our answer would have been that the limit does not exist. And again, that would be the case if these two values here were different. So let's say this was 0, but this was 1. Those two values are not the same. Therefore, the overall limit would be does not exist. And that doesn't say 1, that says D-N-E for does not exist. Again, I apologize for the handwriting. Okay, moving on to today's lesson. So, solving limits algebraically. So now, when we see a limit, notice first of all, I'm not given a graph. I'm also, instead of, if I look at this problem overall, I no longer see the limit as x approaches 1 of f of x or of g of x. I am actually given the equation for that function, not just an f of x or a g of x value. So again, in the future, you'll either be given f of x with a graph, or you will be given the actual equation. So now that we're given the actual equation, this actually makes things a little bit easier for us. Step one is always just plug in the x value that you are trying to evaluate the limit for. So in this case, I take my equation, which is negative x cubed plus 3x squared minus 2, and I'm simply going to plug in the value of 1 because that's the x value that I am approaching. So this becomes negative, the negation of 1 cubed plus 3 times 1 squared minus 2. And so 1 cubed is 1, but then we have that negative out in front, plus 1 squared is 1 times 3 is 3 minus 2. Now make sure, using the rules of PEMDAS, we go from the left to the right. So we're going to add these two numbers first. Negative 1 plus 3 is 2. And now 2 minus 2 is 0. So that means that if I was to graph this function as I approach x equals 1, this is the y value that my function would be approaching both on the left side and on the right side. Okay, so it's as easy as that. Just plug in the x value, and whatever you get, that's your answer. Let's try another type of problem. Okay, so this one's going to be a little different. I now have a fraction, and a fraction now gives me the opportunity to possibly have a 0 in the denominator. And when we have a 0 in the denominator, that's going to be an issue, because if you have a 0 in the denominator, getting the hang, back to my pen. If you have a 0 in the denominator, there we go, that means that you have some sort of undefined function, okay? And then we're going to have to do an extra step. So in this case, if I am evaluating the limit as x approaches 3 of x minus 3 over x squared minus 9, what are we going to do? Well, first of all, again, step one is always plug in. So I plug in 3 for x in both the numerator and denominator. Well, what happens to that? We get 0 over 0. Now, when you get 0 over 0, that means that you have a point discontinuity in the function. What do I mean by that? That means that we're approaching 3 here. I would get some sort of function that looks maybe like this. It's not going to look exactly like that. I'm just drawing something off the top of my head. But you get a hole in the function. So whenever we have a hole in the function, you get a 0 over 0 algebraically. Well, what next steps do we have to do? We're going to factor, cancel out the common factors, and then replug in. Some might ask, why are we doing this? Well, the reason that we're doing this is because even though we have a hole in the function, the overall limit as x approaches 3 of this function still exists. Right? If you were looking at the graph I drew, as I approach 3 from the left and as I approach 3 from the right, what do you notice? They're both approaching the same y value. Therefore, the limit exists. Therefore, it's possible for me to find out what that value is. So that's why we're going to go along with the steps of factor, cancel out the common factors, and then replug in. So what is that going to look like? All right, I'm going to use some space up here, some excess space that I have. Okay, so I'm going to take this function x minus 3 over x squared minus 9. I'm going to factor whatever I can. Well, the numerator is already in simplest form. X minus 3, I can't do anything with that. However, hopefully most of you are noticing that the denominator, x squared minus 9, is actually the difference of two perfect squares. So I can factor this into x plus 3 and x minus 3. Now that you're looking at that, hopefully you can see that we have a common factor. The x minus 3's will cancel out. That will leave us with a 1 in the numerator and x plus 3 in the denominator. Well, what are we going to do with that? I'm just going to continue on down here. Now we are going to reevaluate our limit using our new simplified version of our function. So now when I go and replug back in 3, I'm going to get 1 over 3 plus 3, which is 1 over 6. That is the answer to my question. That would be the y value that my function is approaching as I get closer and closer to x equals 3. Okay? So again, if we get 0 over 0, that means that we have a hole in the function, and we are going to then follow these steps. Factor, like I did here. Cancel out the common factors, which is what I did here. And then we're going to replug in the original limit value. And hopefully come up with an answer, which in this case was 1 over 6. Okay? Let's do another example of each of these situations. So actually at this point, I would love for you to pause the video and try and answer both of these questions on your own. Okay? Take a moment, look back at your notes, look back at the problems that we just did, and see if you can come up with a correct solution to both of these. So take a minute, pause the video, and then when you've come up with an answer for both, come back and look at the solutions. Okay, so hopefully everybody has paused the video, taken time to answer, and let's see how you did. So in problem number 1, I have no denominator here, right? It's just a polynomial. And as a quick hint, when you have a polynomial, your limit will always exist. All right, limit always exists. Why is that? Well, there's no denominator. There's no possibility of having a 0 in that denominator. So therefore, you're always going to come up with a real number expression, and therefore you're always going to get some sort of output value for your limit. All right, well, so we go with the process of plug in. So we are going to plug in 2 because that is what we are looking for as x approaches 2. So we have 2 squared minus 4 times 2 plus 9. 2 squared is 4. 4 times 2 is 8. Again, following our rules of PEMDAS, we are going to go left to right with our addition and subtraction. So 4 minus 8 is negative 4 plus 9. And we get an answer of 5. That's really messy, of 5. So let me write that again. We get an answer of 5. All right. Hopefully you agree with me. Hopefully that's what you got as well. Moving on to the second problem. Well, right away, again, I'm noticing that I have a denominator here. So there is a possibility of getting that 0 over 0. So we have to be very careful. Now, just because I have a fraction does not mean that you should automatically go to a factoring place first. Because there are some fractions where you can't factor it. And so you might be trying to do all this factoring work for no end. All right? You might just be wasting time. So make sure, even though you see a fraction, you are still plugging in first. Now, when you plug in, you're going to get 1 squared minus 3 times 1 minus 4 over, that's a negative 1 that we are approaching. So I just did that wrong. X is approaching negative 1. Well, negative 1 squared is positive 1. Negative 1 squared. This is going to be minus 3 times negative 1, which is going to come out to become a positive 3 minus 4. Then we get negative 1 plus 1. So we end up with 0 over 0 again. Okay? If it wasn't 0 over 0, if this came out to be 5 over 6, well then 5 over 6 is our answer. Okay? Again, just because it's a fraction does not mean we're automatically always going to have to factor. You have to factor only when you see this 0 over 0 after you plug in. Okay. Well, now let's go with the factoring process. So I have a trinomial in my numerator. So I'm looking to see, actually I'm just going to clear this up a little bit just so I can write in some extra work. All right, we're in step 2 now of factoring. All right, so I need to see when I factor this trinomial what multiplies to -4 and adds to -3. Well, multiplying to -4 and adding to -3, that's an x minus 4 and an x plus 1 in the numerator divided by our x plus 1 in the denominator. Kind of a helpful hint, if I get 0 over 0 and my goal is I need to try and cancel out this denominator, it's probably a good possibility that I'm going to end up with that same factor in my numerator. So that should be kind of a helpful hint on how to, find your factors a little bit quicker. If there's an x plus 1 in the denominator, there's probably more than likely going to be an x plus 1 in the numerator so that they cancel out. Which again, in this case, is exactly what happens. The x plus 1s cancel. That leaves me with x minus 4. So this is now the new simplified version of my original function. And I am now going to reevaluate my limit using this simplified function. That was a parenthesis that was supposed to be there. So we are just going to simply now replug in. And so we're plugging in the -1 for the x value minus 4, and -1 minus 4 is a value of -5. So that's what we come up with our answer for that one. Hopefully you all agree with me, or if you didn't agree from your original work, you now see why it is -5 for that problem. Okay, moving on. All right, we've got a bunch of questions here. I know it says group work. Sorry, I didn't change it from when our original lesson format. But again, I'd like you to pause the video at this point and see if you can come up with the correct responses to all of these functions. Okay, take a moment to pause, and then we'll continue on when you get back. Okay, so hopefully you all spent a good amount of time trying to come up with these solutions. As you can see, I've done them myself. And so here's what we get. Well, question number 1, simply just plug in. You get 3 as your answer once you simplify. Question number 2, here's what I was saying before. Here's a fraction, but you do not have to factor this fraction. So don't even attempt it. Okay, you'll be wasting time. If you plug in that 1 right away, you're going to get 2 plus 1 over 3 minus 2, and you get 3 over 1, which just reduces to 3. That's your answer. No factoring needed. Same thing. Oh, there's no question 3. I guess I skipped a column here. All right, question number 4, same thing. Even though this looks like one where you might think, oh, guaranteed, gonna have to factor this. You actually don't have to factor it. When you plug in, okay, you go right to 1 minus 1 minus 2 over 1 minus 2. That's a -2 over -1, which just simplifies to +2. No factoring needed. Now, 5, 7, and 8, however, when you plug all those in, you end up with 0 over 0. So in this case, for question number 5, after you plug in 0 over 0, we're going to do our factoring. We see that we have an x minus 2 as our common factor. So that's going to bring us over here to evaluating our limit again of our simplified function. So the only piece left in this function is x plus 1. That's what I have right here. We're going to replug in that 2 into x plus 1, and so we come out with 3 as our answer. Okay, moving on. Question number 7. Again, we get 0 over 0. X squared minus 9 can factor using difference of 2 perfect squares. We then see that our common factor is x plus 3. And so now we reevaluate our limit as x approaches -3 with our simplified function here. And after we plug that in, -3 minus 3 is -6. Okay, so that's our answer there. And finally, question number 8. Question number 8, again, we get 0 over 0 as our answer. And when we factor, okay, difference of 2 perfect squares in the numerator, the denominator, we might have to remember our SOAP method. Okay, a little bit more difficult when you have that leading coefficient that's greater than 1, but we do end up with a 2x plus 1 and an x plus 3 as our factors, allowing us to simplify, cancel out that x plus 3 factor, which brings us over to our simplified function of x minus 3 over 2x plus 1. And after we plug in here, we get a negative 6 over negative 5, which again, because you have a negative divided by a negative, we can simplify that to a positive value. And so we end up with 6 over 5 as our final answer. Okay? All right, now last problem. Kind of what our exit ticket would be. Again, if you would, please take a minute, pause the video, and try and answer this question correctly. Okay, so take a minute, pause, and we'll come back in a second to see how you did. Okay, well, as you can see, I didn't actually fully finish the problem yet, but at least this is how we start. So if I were to plug in 8, because that's what my x value is approaching here, I would end up with our 0 over 0. So again, that's telling me that I have a hole in my function at that x value. Now, when we go to factor, again, the numerator is the difference of two perfect squares, so I can see that x minus 8 is my canceled factor. That leaves me with x plus 8, as our final simplified function, and so when we replug in, we're going to get 8 plus 8, which gives us 16. So hopefully you are all able to get that correct answer. I hope this was helpful. Okay, there will be now a homework assignment for you to complete as well. And please let me know if you have any other questions. Okay? Now, for those of you, I kind of mentioned before, for those of you who are still having issues with the graphing aspect of things, I actually have one more slide that I'm going to go through at this point. But if you are feeling confident with the graphing aspect, you could stop the video now and just go straight to the homework. Okay? All right, so for those of you who are still having questions with the graphing aspect of things, here's just one example that we're going to go through. We've got quite a few questions here that we can answer from this graph. So question number 1. All right, we have the limit as x approaches negative 6 from the left. And again, we know it's from the left because of that negative exponent we see after the negative 6 value. So here is negative 6 right here. Okay, that's negative 6 on my graph. So I want to look at the function approaching negative 6 from the left-hand side. Well, here's my function to the left of negative 6. So I'm going to follow that function down, and I'm going to stop when I reach that line. Oh, I went a little too far. When I reach that line at negative 6, right? Because here's negative 6. You can all see that line that negative 6 is labeled at. So right when I stop there, I'm looking, what y value is it that I am approaching? Well, I'm going to move my eyesight right over, and it looks like that y value that I approached right there was at negative 2. So that's the answer to that limit question. Well, now we come over here to question number 2, and now we're asked for negative 6 coming from the right-hand side. So again, here's negative 6. I can clearly see that line on the axis defined. So now I'm going to follow the function from the right-hand side. Now, I don't have to go all the way over here to the furthest point on the right. That's a little excessive. I just need to go kind of immediately to the right of where negative 6 is. So kind of over here, negative 5, negative 4, here's where that function is. Well, again, I'm going to follow that from the right, going back towards my x value of negative 6. And what y value am I approaching? Well, it's the same y value as last time. As I move my eyesight over to the right, to the axis, I see that y value is also negative 2. So question 1 and question 2 are both the same thing. Now, it doesn't list it here. I must have skipped that question, but I'm going to add in a question number 3. If question number 3 then said find the limit as x approaches -6 without an exponent, that means I'm looking at the overall limit. So again, I'm asking myself, does the left-hand limit equal the right-hand limit? And in this case, because the answer for question 1 and question 2 was the same value, that means my overall limit would also be an answer of -2. Okay, moving on to question 4. Question 4 is now saying find f of -6. Well, f of -6 just simply means, sorry, I'm going back to erase. F of -6 just simply means when you're looking at x equals -6, what is the y value of your plotted point? Now, your plotted point, remember, is your closed circle, not your open circle. So if I go to -6, I have two main things here. I have an open circle at -6, and then I have this closed circle dot at -6. I am looking not at the open circle part, but I am looking at the closed circle. What is the y value of that point? Well, again, if I go back, shift my eyesight over to the axis, that is a y value of 2. So that is my answer for that question. All right, now I'm going to clear up this graph because now we're moving on to some different x values here. Okay, next question, number 5. The limit as x approaches -4 from the left. Well, here is -4. I can clearly see the axis line, right, up and down. I can clearly see that line, so that's going to be helpful for me when I'm trying to figure out where to stop when moving along my graph. So coming from the left-hand side, and I stop at x equals -4. Actually, it looks like I stopped a little too soon. If I stopped at x equals -4, what is the y value there? Well, again, I'm going to come back over, and it doesn't actually have a number listed, but that's halfway in between 4 and 2, so that looks like it's going to be a 3 to me. I don't know about what you guys think. All right, number 7. Well, now number 7 doesn't have an exponent, so it's not looking at the right hand or the left hand separately. It's looking for the overall limit. So the overall limit at -4, here's -4 again. I need to see, does the left side and the right side both approach the same y value? Well, I don't know about you, but looking at this graph, looking at the arrows that I drew, because the function is going to connect, there's no break, there's no jump, there's no hole, that function from the left and from the right is approaching the same y value, and that y value is 3. Now, separately, question number 8 is asking, okay, we've dealt with the limit. Now let's go back and what is the y value at -4? So again, we're looking for the closed plotted point. Now, just because there isn't actually a visible, like, circular dot like there was for -6, that doesn't mean that there's not a point here, right? If I go to -4 and I go up to where my graph is, all right there, is the point that is plotted at x equals -4. And what is that y value? It is, again, 3. So in this case, 5, 7, and 8 all have the same answers. And notice what's happening, though, at -4. You have a continuous piece of the function at x equals -4. So that should mean something. When you have a continuous piece of the function, you are going to have your left-hand limit, your right-hand limit, your overall limit, and your f of -4 all equal to the same value. All right, I'm being told on the video recording that I only have about 30 seconds left, so I'm going to go through these last ones pretty quickly. All right, so x approaching -1 from the right. All right, x approaching -1 from the right. Well, I'm going all the way down to -infinity there. My function's going down, 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 all the way down. All right, if I'm approaching -1 from both sides, well, this was the right-hand limit, this is the left-hand limit. They're both going down to -infinity, so my overall limit is at -infinity. And I'm about to run out of time. So just to tell you, this answer would be 4 and this answer would be 0. Hopefully that was helpful. See you guys in the next lesson.